We have another example on the board. This time we are going to start from right side. Please notice that on the right side we have the square of the sum. What I mean by that? We're supposed to use this formula. A plus B square. Okay, this is the square of the sum. And I have A square plus 2AB plus B square, where this is going to be my A and this is going to be my B. Okay, so let me rewrite right side first. I have sine half of alpha. That's why I'm going to write this angle like alpha over 2 plus cosine, the same situation we have over here, alpha over 2. And everything is raised to the second power. Next, I'm supposed to apply this formula, okay? So this is my A. It has to be squared. I have sine square alpha over 2 plus 2 sine alpha over 2 cosine alpha over 2 plus cosine square alpha over 2. Next, I'm supposed to realize that sine square angle plus cosine square angle is equal 1, because I'm supposed to use the Pythagorean relation. Let me rewrite this problem in order to make it visible. I have sine square alpha over 2 plus cosine square alpha over 2 plus 2 sine alpha over 2 cosine alpha over 2. Sine square alpha over 2 plus cosine square alpha over 2 is equal 1, because sine square of an angle plus cosine square of the same angle is equal 1. That's why I'm going to write 1 over here. Plus, this is the sine of twice an angle. That's why I'm supposed to rewrite this as sine 2, and I have angle, which is alpha over 2. Now, this is nothing else, just multiplication. 2 and 2 will cancel out. And I'm going to end up with 1 plus sine alpha. Now, let's take a look at what we have obtained. We got exactly the same expression which we have on the left side of our identity. So this is the proof that the left side is equal to the right side.